So I'm on the June 2009 vectors question, and my maths shows me that there are 17 marks available for this question. So I should be able to get some marks from this, if not all of them. Right, so first fairly standard question from some information given to me. Find the vector equation of the line L. Now L passes through, well, I'll write out the way that we write a vector equation to start with. And if we know that it passes through 2 points, A and B, then we can find the direction between those points by doing B subtract A. And the first vector has to take us from the origin up to a point on the line. Now we've been given all of this information because our vector that takes us up onto the line, like we're told that A is on the line, so we can use that, or we can use B. So I'll use A, but you could have used B. So notice it says a vector equation, not the vector equation. Plus lambda times the direction. Now the direction comes from doing B, right, subtract A. So if I do 10j, take 8i, I'll get 2i. If I do 14j, take 13j, you'll see I will get I. And if I do my B is minus 4k minus 2k. That minus and minus gives me a plus. So it would be minus 4k plus 2k gives me minus 2k. So that is the first part of the question done. The second part of the question says find the magnitude of the vector that takes us from C to B. So we've got C and we've got B. So this is an application of Pythagoras rule. So I'll just put the parts in here. So using Pythagoras rule, then I can ignore negatives. So I can do the square root of the difference between the i's, which is 1. I've got to square root that. The difference between the j's, 9 and 14. So the difference between the 9 and the 14 is 5. So I've got to square that. And the difference between 6 and minus 4, which is 10, I've got to square that. So this will come to the square root of 126. I'm sure you can work that out. And that, using surds, will reduce itself down to 3 square root 14. So the video has been running 2 minutes 45 seconds. We've picked up fairly straightforward 5 marks. You would want to be getting those marks on any C4 exam. Now, fairly common question that we're asked is to find an angle. Right, we need to find the angle between the line segment CB and the line L. We already have the direction vector for the line L, and we already have the magnitude of CB, so we've got bits that we need. I'll just remind you what we need to do to get an angle. Right, we use the dot product, and our dot product rule is as such. The bits that we've already got, I'll put them in first. Well, we've got our CB part, so we've got 3 root 14, and we'll have to dot that with the magnitude of the direction vector on our line, which we'll do in a moment. And on the top, we've already worked out. Just have a look, C and B. So we've already got our direction vector here. And then our part B, look for that. And I've got to use my CB part here. So my CB then, 10, there will be B minus C. So 10 minus 9 is 1. 14 minus 9 is 5. So I've got I plus 5j, and then I've got minus 4k minus 6k minus 10k. So that is the, so what I'm actually doing is not clear to you. I'm doing C to B, which is B minus C. So I've taken 10 subtract 9, 14 subtract 9, minus 4 minus 6, giving me the I 5j minus 10k. Now the direction vector of the line we have here, so that's 2i plus I minus 2k. We've already, in this part, worked out the magnitude of BC. So I just need the magnitude now of the direction vector on the line L. And that would be 2 squared plus 1 squared plus 2 squared, which comes to 9. Square root of 9 is 3. So now we need to do the dot product at the top, and we'll see that that's 1 times 2 is 2, 5, and then 20, which comes to 27. So we have 27 over 9 or 14. Push that through the calculator, inverse cos with our angle of 36.7 degrees. Right, so on to part D, and really to do part D, you need to do a diagram. So I'm going to put the diagram in and put the information that we've got already. Now we've got C, we know, and we've got B, who's on our line. We know that CB is 3 root 14, and we know that the angle between CB and the line, which we just worked out, is 36.7. So the shortest distance will be at a right angle, so therefore this length x is found by using trigonometry, finding the opposite side with the hypotenuse and the angle given. So length x will equal 3 root 14 sine 36.7 degrees. Again, I'm quite sure you can do that on a calculator. So x equals 6.708. On to the final part then. Final part of the question wants me to find the area of the triangle, the area of this triangle. Now if I drop a perpendicular down to here, then if I can get this height from the information, actually it's not quite the right way to do it. I'm going to put into here the length that I've got. There's a number of ways you can do this. The way I've chosen to do it is to take this angle away from 90, so 36.7 away from 90 is going to be 53.3. So 53.3 there. So I want height there. So I'm going to use the formula half AB sine C. So C is the included angle between these two lengths. So it's simply going to be a half times 6.708 times 3 root 14 sine. I've done that calculation in my head. 53.3. That came from 90 subtract 36.7. And if you work that through, you will get the area of the triangle, which I haven't actually written down on my other sheet that I was taking all the answers from to make sure I got none of this wrong. So we'll just have to push that through the calculator to get the answer. There you are, there's 17 marks for you, done in 8 minutes, 12 seconds, flawlessly. Mr. Bradford, Featherstone High School. Good afternoon.